Okay, let me just now switch over to seeing one of the main architectural modeling environments, just to give you the idea of how Edificius solves complicated problems in the world of 3D BIM modeling in a simplified manner with an intuitive architectural interface. Let me just quickly show you how the software is organized first of all. You have on, if you see the screen jumping, Rokas, I'll go back quickly, okay, just in case
Yes.
We need to recover certain parts of the presentation.
Dabar parodys pagrindinius Edificius programos struktūros sudėtinės dalis ir kaip programa yra struktūruota ir kaip jinai veikia ir dirba.
So you can see here, in general, the interface is quite simple in the sense that we have the project navigator on the left-hand side organized vertically from top to bottom, where we have all of the descriptive information for our project, leading through down to the bottom where we see the construction documentation, where we have all of our drawings and all of the relevant project data.
Kairėje pusėje yra pagrindinė projekto struktūra, kur viskas pakankamai aiškiai aprašyta ir apačioje yra taip pat programos papildomi plėtiniai suteikiančias papildomą funkcionalumą.
And you can see here towards the bottom left-hand side, we also have the environment switcher, which allows us to switch between different modeling environments. So whether we're dealing with the architectural design or the terrain modeling, landscape modeling, or for instance, the 4D Gantt, organization of the construction process, and others, including the MEP systems, we just simply click on these buttons here and switch from one environment to the other.
Kairėje pusėje apačioje yra pagrindiniai modeliavimo aplinkos, kurias galima keisti paspaudus ant jų. Ir, pavyzdžiui, paspaudus ant architectural design būna architektūrinė aplinka skirta pastatų modeliavimui, ant terrain gerbuvio modeliavimui, Gantt 4D būna aplinka skirta statybos proceso organizavimui, grafikų sudėliojimui, remiantis su modeliuotu modeliu, taip pat yra sąmatos aplinka ir papildomos integracijos su kitomis programomis.
Okay, then we have on the right-hand side, you can see here the properties box. This populates with data and information relating to the objects as we choose them from the architectural objects menu. So basically we have a series of different settings which, let's say, describe the properties of each of the different objects.
Dešinėje pusėje yra parametrų langas, kuriame yra pasirinktų objektų parametrai ir nuostatos.
Let me just give you a brief example of how we can start modeling. We're just going to do a quick example, Rokas, okay? So explain that this is just one of the many different workflows that we can follow. Many architects may need to, for instance, start their BIM modeling starting from a CAD file, which is also included in Edificius. We're going to see that. Or maybe in a typical and more straightforward manner, we may want to use a typical construction grid, which we have here in the menu box.
Dabar pademonstruos vieną iš galimų modeliavimo pradžių, tačiau galima ten kiekvienas architektas ar projektavimo įmonė turi savo praktiką. Galima pradėti arba nuo, kaip čia dabar Tonis rodo, nuo tinklelio, ašių tinklelio, tačiau lygiai taip pat galima ir pradėti darbą, kiti architektai kaip yra labai pratęs nuo dvimačių brėžinių arba eskizų koncepcijų pasiruošimo. Tai Edificiuso komplektacija eina ir nemokamas Edificus CAD, kuris pilnai atitinka autokadinį funkcionalumą. Mes kaip tik pas mus įmonėje dabar išsibandėme, tai labai patogi programa. Ir ir o čia dabar rodo, kaip tas viskas atrodytų, jeigu pradedat modeliuoti iškart trimatėje erdvėje.
Okay, so let's just imagine that, for instance, we have a typical layout of the intersection points between beams and columns, or the intersection points between different masonry walls. We're going to build up a construction grid, okay? This will serve the purpose of giving us a guideline, let's say, where we want to insert our various objects. We call this the 2D magnetic grid. Magnetic because all of the objects that we insert upon it automatically aligned to the grid.
Čia yra padarytas panašiai kaip katašių tinklelis, prie kurio automatiškai prisikabina visi ir orientuojasi visi objektai, kurie bus kuriami, ir jeigu reikia projektuoti objektą, kuris būtų siejamas su šiuo ašių sistema, tai yra pagalbinis įrankis, kuris padeda efektyviai naudoti ir modeliuoti programos objektus.
So I'm going to lock the grid into position and show you briefly how this object works. One thing I'd like to underline, Rokas, is the fact that the interface here at the top, the toolbar, remains very, very simple in the sense that the user is proposed with only the tools that he needs when he needs them. It means that no complicated buttons or functionalities or sub-menus. You only see the tools that you need according to the phase of design that you are covering.
Labai svarbus aspektas, į ką atkreipia Tonis, tai yra, kad viršutinėje meniu grafoje, kur yra išdėstyti mygtukai, jie yra filtruojami ir kad matytųsi tik tos komandos, kurios reikalingos darbo metu, neapkraunant interfeisų papildomais mygtukais, kurie tiesiog labiau sukuria tokį sudėtingumo įvaizdį. Yra atskiriama tik tos komandos, kurios tame kontekste darbo etape labiausiai reikalingos.
Okay, so let's go and grab one of the first objects of this example where we're going to insert a wall. Let me just show you. You may be very familiar with the fact that walls are not just simple geometrical representations. They contain different materials. And we can achieve, let's say, this advanced functionality of being able to choose the composition of our walls by going into the library. The library proposes a series of different combinations. We can, of course, insert these walls using the snap points on the 2D magnetic grid, or we can use the magic wand, it's called here. So what we do is we simply select the magic wand and run a selection rectangle over all of the lines of the 2D magnetic grid. Notice how all of the objects stick to the different lines and intersections of the 2D magnetic grid.
Elementus galima juos arba dėti rankiniu būdu, pritaikant prie susikirtimo arba užkabinimo taškų, arba naudojant specialią komandą magnetic wand, su kuria ten automatiškai susideda pagal užbrėžtus parametrus sienos pagal suformuotą tinklelę.
I'd also like to underline the fact that this library of objects, which of course covers many different categories, is now available in the cloud. It means that we can all collaborate and build our own user objects, let's say, and have them shared among our architectural firm, or for instance with the entire Edificius community, if we wish. So you have the full power at your fingertips to be able to, choose your preferred way of working.
Objektų biblioteka ir Sienų biblioteka ir kitų objektų biblioteka yra pagrįsta tuo principu, kad objektai yra saugomi debesyje ir dėl to vietoje architektams lengviau bendradarbiauti, nes gali tiek įmonės lygmenyje būti skirtingi sukuriami objektai, kurie tarpusavy bus naudojant vystomi projektą arba netgi dalinamasi su visa bendruomenė naudojančia šitą programinę įrangą. Dėl to būna tos bibliotekos jos šiek tiek laisviau dalinamos, prieinamos ir užtikrinančios darnesnį darbą.
Okay, so now we've just chosen a different material layer for our wall. We're going to insert the internal partition walls, okay? Now, this approach allows me also, for those that come from CAD, from 2D CAD, to maintain the most familiar way of working, also in a 3D BIM software such as Edificius. So we can continue to insert our lines and therefore generate our internal partition walls. We're just doing this very randomly, just to give you the idea.
Sienų nustatymas vis vyksta labai panašiai taip, kaip vyksta dvimatėje braižymo programoje, išlaikant pagrindinius principus, įvedant atstumus ir taikantis prie nustatytų ir užtvirtintų konstantų.
Okay, so as we insert these walls and start to define this first level of the building, let me just quickly show you some of the basic functionalities of where we can simply remove, replace, change the thicknesses of our walls, or just simply move from one position to the other, because we're configuring the, let's say, overall layout for this first floor plan, okay? And here, for instance, we're going to remove these parts of the external facade. Go ahead, Rokas.
Tai kaip pat įrodė Tonis, sienos gali būti keičiamos, iškertamos, koreguojamos, parametrai pakeičiami ir pakankamai su nedaug pelytės paspaudimų gaunamas rezultatas. Jeigu lyginant su dvimatėmis programomis, tai pelytę maigyti reikia daug mažiau.
Okay. Here we can, for instance, change the properties of these walls here, changing to a different thickness and a different material composition. In this case, they're going to be clay brick walls. Now, what we have achieved so far is the 2D view. We were drawing in 2D view, but of course, we've also obtained the 3D view of our walls.
Ir sienoms priskyrė konkrečių sienų gabaritus ir suformuotas buvo dvimatės vaizdas ir taip pat trimatė pirmo aukšto geometrija.
And for instance, those of you that may be familiar with other 3D modeling solutions, maybe we want to continue modeling in 3D. And the software, as you can see, allows us to do just that by accessing the 3D view, choosing the objects. In this particular case, we're going to see the internal openings and insert them directly in 3D. We don't need to do any specific settings for geometrical, let's say, characteristics, because we can use these blue anchor points to vary the geometry or, let's say, assign different values.
Ir geometriją galima toliau koreguoti ir keisti trimatėje erdvėje, naudojant tuos raktinius taškus mėlynus, nustatant įvairius parametrus ir angų gabaritus.
Here we're going to insert another opening here in this part of the building and use the anchor points from another object to give them the same height. We can add other details such as casings, framings directly in 3D.
Rangos užbaigimas, tiek visokiausi tai aprėminimai, apkalimai, uždarimai pilnai išsisprendžia trimatėje erdvėje ir atsispindi planuose.
Here we're going to insert some of the internal doors just to give you an idea of how we're organizing the internal arrangements of access to the different rooms. Here we can choose them from the library. We can build our own, and using the F5, F6, F7, and F8 function keys, we can therefore change the alignments too. We can also do some minor visual checking of these internal doors by giving them an opening angle. and also do
Pasinaudojus
copy-pasting.
raktiniais mygtukais F7, F8, F9 galima įstatymo metu keisti orientaciją ir varstymo kryptis ir per parametrus nustatyti trimačio pateikimo grafinės galimybės, kaip kad daryti duris pusiau atidarytas ar panašius dalykus.
So, as I was mentioning earlier on, we have this intuitive approach where the interface adapts to our needs according to the different objects. Let me just show you this in action when we open up a very important object for any kind of building, which is the stairs object. As soon as we insert the general, let's say, footprint of a stairs object, this dedicated editor opens up. Okay?
Ir išlaikant visą programinės įrangos logiką ir principą, kad rodomos tik tos komandos, kurios reikalingos tuo metu, dabar Tonis parodės, kaip yra sukuriami laipto objektai ir pasirinkus laipto konstravimo įrankį, iškart atsidaro meniu ir aplinka, kur reikalingos komandos tik tais laiptų konstravimui.
In fact, here you can see that we have a 2D view on the left-hand side and a 3D view with a slight transparency of the other objects which are not relevant directly to the stairs. So what happens is you'll be able to see that, first of all, the objects menu here at the top is populated only with those objects which I need in this particular case. Another interesting functionality is the fact that as we build up the stairs and, let's say, build up the its pathway towards the upper levels, you can also see that the ramps automatically connect and define the riser and the tread height values.
Vienas iš tų irgi, kad, kaip jau minėjo, kad meniu prisitaiko, nebūna perteklinių komandų ir kad konstruojant elementus, laiptų aikšteles, galima iškart matyti ir trimatę erdvę, kaip konstruojasi ir iškart prisitaiko tiek pakopos, tiek laiptatakiai automatiškai ir susiriša į vientisą laiptų objektą.
So here we can see different objects which are being connected. This is just a simple example, of course, but stairs can be very, very complicated geometrical objects in any project, especially if it's an existing building. But one thing you can see here is that the starting slab and the arrival slab are automatically defining the altitude difference for the stairs object. Okay, so this is also very intuitive to use.
Laiptų kūrimas yra padarytas labai paprastas ir intuityvus ir tiesiog modeliuojamas jutiminiu pagrindu, o aukščiai ir pakopų dydžiai automatiškai generuojami pagal bendrus projekto ir aukštų parametrus.
Another object which is also relevant to the stairs design is, of course, the railings. Let me just quickly show you how the railings automatically connects up to the stairs object. We also have some automatic functions which allow us to insert the intermediate poles directly on the stairs.
Kiti įrankiai, kurie yra taip pat, kaip rodo, kaip galima panaudoti laiptų turėklus, pasinaudojant turimais įrankiais irgi pakankamai paprastai, efektyviai ir intuityviai.
Here you can see that the poles were inserted automatically according to the evolution of the stairs. Just to show you the other capabilities referring to staircase modeling and complexities of the geometry of the stairs, we're just going to make a copy here, bring it to one side, and enter into edit mode again, and do some minor modifications to the landings, the ramps, also by defining, for instance, round steps rather than straight linear steps.
Dabar pademonstruos, kaip atrodytų, jeigu tie laiptai turėtų būti šiek tiek netokie tipiniai, o su skirtinga geometrija.
Okay, so let's just continue now. So this is the let's say, the general perimeter of how we can design any kind of stairs object directly in 3D. Okay, we'll continue the project modeling so far for this first floor, for the ground floor actually, and insert some other objects. We're going to see the insertion of other doors, windows, balconies, and other relevant objects like that. Of course, we can do all of the geometrical variations directly in 3D, or by simply varying the parameter in the inspection box here on the right-hand side.
Ir visus parametrus modeliavimo metu galima arba trimačiame lange nustatyti, arba per parametrų langą irgi taip pat nusistato visi parametrai, kurie reikalingi.
Here's another object which we can also customize and create for ourselves in the BIM library. Let's now insert this object into our project. Of course, we're doing this in the 2D CAD approach, but we're also building up the 3D model, as you can see again here. We can add further details, change the materials, add door sills, thresholds, and other elements which characterize the design sense and style of our project.
Visus parametrus galima irgi nustatyti trimatėje, tokius kaip kad rėmus, užbaigimus, aukščius, įstatymo gylį, palangės parametrus per parametrus.
Let's say that we figured out more or less the main definition of this reference ground floor, and we want to now start building up and evolving the project across the different floor levels. So for this case, we're going to use the height reference system or the levels and sub-levels manager, where we're going to define the number of floor levels for our building.
Ir sekantis etapas yra, kad nustačius bendrą pastato pirmo aukšto kontūrą, to vietoje galima nustatyti aukštų struktūrą, kurio pagrindu toliau bus konstruojamas visas architektūrinis modelis.
So as we do that, the software is now adopting the height level management system, and we are now capable of selecting all of the elements in the source floor level. Okay, so the source floor level in this case will be the ground floor level. This is where we started modeling, and we're now going to copy all of these elements to the other floor levels here as defined.
Ir nustačius aukšto struktūrą, galima iš pirmo pagrindinio motininio aukšto paimti visus elementus ir nukopijuoti per visus kitus aukštus, kurie reikia numatyti pastato struktūroje.
You can see that we have the copy toolbox here on the right. As soon as we bring up the copy toolbox, we can decide which entities we want to copy and where we want to copy them to. A simple click of the green checkbox automatically sends all of the objects copied to the destination positions at the destination floor levels.
Ir visi automatiškai objektai susideda į kitus aukštus pagal savo vietą ir sukuria aukštų struktūrą.
Okay, and at this point, here onwards, we can continue doing our modeling and editing and varying the composition of our floor levels by simply selecting and removing or selecting and rotating the various different objects. So for our project here, we're going to remove this part of the building at the top. We're going to create a terraced rooftop here. And we're also going to insert these other objects. Another interesting feature is the possibility to copy the properties of, for instance, these windows and insert them randomly into position. So, for instance, this speeds up the insertion process because we can now use the align function which appears in front of our eyes. It's a useful tool, which allows me therefore to decide which axis we want each of the different objects, in this case the windows, to be aligned to.
Ir modeliavimas toliau gali būti tęsiamas trimatėje erdvėje. Langai kopijuojami, statomi ir lygiuojami vieni kitų atžvilgių arba kitų statybinių elementų atžvilgių.
Then maybe here we want to change the style of this entrance door, and by simply, instead of just simply deleting and inserting a new door, we can copy paste the properties from one door to the other. Copy and paste. Okay?
Ir taip pat galima kopijuoti skirtingus parametrus, o ne tik pačius objektus.
Then, of course, we have to deal with materials. We want to also use, let's say, different materials to define the exteriors of our building. We'll see a lot more about materials and textures afterwards. But the general idea here is to make sure that the designer, the architect, can focus on what he's good at, which is building and building design. Whereas we take care of all of the other aspects, even relevant to creating textures, where we have over 5,000 different textures, which are already, let's say, optimized for usage with the different rendering engines what we provide inside of Edificius.
Ir trimatėje erdvėje pasikonstravus geometriją galima priskirti įvairioms plokštumoms, ne tik elementams medžiagiškumas, ir yra sukurta medžiagų biblioteka iškart pritaikyta skirtingiems renderinimo mechanizmams ir turinti daugybę, apie 5000 skirtingų medžiagų, leidžiant pakankamai greitai ir efektyviai viziją architektūrinę perkelti.
Another object here, we can say we're now moving to the roof level, and in this particular part of the building, we're going to concentrate on another editor, which is a dedicated, intelligent editing mechanism for rooftops. Here we can choose the rooftop footprint, insert it into position here. Notice how the software understands the need for a dedicated environment and therefore leaves the architectural modeler to bring us into the stairs editor. Okay, this is where we can either choose to model our roof slabs manually or use the automatic pitch generator according to a given roof inclination expressed in percentage, and it will automatically build up the pavilion rooftop. Here we have full control. In fact, we can continue to select the individual slabs and, for instance, remove and do geometrical editing directly within this environment here, as you can see.
Ir pasirinkus stogo įrankiai, taip pat kaip ir laiptų atveju, persijungia programa į stogo kūrimo režimą, kur galima visas kitos komandos išjungiamos ir paliekamos tik aktualios stogo kūrimui ir pati aplinka pasikeičia susifokusavusi apie stogo kūrimą ir ko galima tiek stogą sukurti automatiniu režimu arba tiek pakeisti jo geometriją rankiniu būdu.
Okay, so in this particular case, we're going to delete the rooftop. That was just an example.
Dabar ištrinsime viršutinį tą stogą, kuris buvo tik pavyzdys.
Okay. Going to delete that. And what we want to do now, Rokas, is just simply give the general idea of how to work in 3D and 2D to build up our example of this building, which therefore would lead us to discovering other important modeling environments. Now, let's just imagine that we've finished off this building, okay?
Ir dabar parodys, kaip veikia, kaip pastatas jau yra išmodeliuotas, kaip veikia sąveikoje su kitomis modeliavimo aplinkomis.
Yeah, we were using the different objects inside of Edificius, okay? Intelligent BIM objects with their own parameters and characteristics. But maybe we need to also do some more advanced modeling, which we can't do directly inside of Edificius. Just imagine, for instance, organic architecture and the possibility to therefore leverage other software solutions in a more collaborative workflow. This is where we see the integration with SketchUp, Blender, and also Rhino Grasshopper.
Dabar parodys, kad sukuriant objektą, sukūrus pastato struktūrą iš standartinių programinės įrangos objektų, jie yra patys valdomi pačioje programoje, tie parametrai, taip pat kaip ir kitose panašaus tipo programuose. Tačiau jeigu atsiranda architektui poreikis išgauti kitokias, organiškesnės ir netokias geometriškai taisyklingas formas, yra programoje numatytos betarpiškos integracijos tiek su SketchUpu, tiek su Blenderiu, kad tuos objektus išmodeliuoti iki tokio tikslumo ir tokio detalumo ir tokios netaisyklingos geometrijos, kiek yra reikalinga, norint pasiekti architektūrinį rezultatą.
Yes, so what we're going to see in this particular case is we've selected a part of the building, and this will serve the purpose of bringing the reference objects directly into SketchUp. And this is where, for instance, we can load our own objects, we can do some modeling, and therefore define some very strange, let's say, architectural solutions. In this particular example, you're just going to see a brief object modeling workflow with a simple, let's say, protection system on top of this patio window, just to give you the idea. We're doing this inside of SketchUp. We could do this also inside of Blender, if you wish. You can also use the materials, save, and here we are back in Edificius, where we have imported these two objects, which were originally created inside of SketchUp.
Ir čia parodėme pavyzduką, kaip programa integruojasi su SketchUpu ir turi dingišką integraciją su Blenderiu, kad galima padaryti įvairią netipinę objektų sienų arba bet kurio kito architektūrinio elemento geometriją.
Here we're seeing the same kind of, let's say, workflow by adopting the integration with Rhino Grasshopper. Here we can integrate these 4 columns, connect them into Grasshopper, create our definition inside of Grasshopper, and, for instance, generate this organic trellis structure-based covering for the bus station project that we were working on inside of Edificius. Here we can just simply do our thing, save, bring it inside of Edificius, and just to give you a brief glimpse, a brief preview of the real-time rendering capabilities, you can also produce these renderings or animations.
Ir taip pat programa turi sąsajas su tuo Grasshopperiu, kuris leidžia padaryti sudėtingą tą geometriją parametrinę, kai reikalingas organinės architektūrinės formos.
Of course, the need for highly detailed construction drawings, floor plans, section views, cutaway drawings, isometric views is also something very important, even when we're talking about BIM. And here you can see the different ways of being able to visualize our construction documentation, which is, of course, something which is left to the creativity and the visual requirements of each architect. So you also have the possibility to customize the way we produce our drawings. We can also view, for instance, the material layers that were, of course, included in the library. So if we activate the checkbox, we can also see inside of our drawings the materials which are composing each and every wall or slab.
Ir šita programinė įranga duoda labai plačią galimybę dirbti ir privesti architektūrinės dalies brėžinius prie norimos grafinės dalies. Ir čia vat yra kaip pavyzdys, kaip tai gali atrodyti.
Yeah, so you can start to see some of the characteristics here included in our drawings. Let me just quickly activate a cutaway drawing. You can see in 3D, we've run a section plane across the first floor. You can see the different material layers represented with their symbols.
Čia rodo, kaip atrodo tos sienos ir kaip skirtingos medžiagos pateikiamos trimatėje erdvėje su savo atvaizdavimo taisyklėmis.
Okay, in this point, we have full control of each material layer, which we can also adjust, edit. We can also set a different inner or outer face. So we want the outer side of the wall here to be with insulation panels.
Ir pilnai šito sukonstruotos kompozitinės sienos struktūros galima keisti į išorinius sluoksnius, nustatant apdailos parametrus, tokie kaip numatyti architektūriniai idėjai.
And now let me just quickly show you, because we have full control, we are also making decisions regarding the project. You'll also be able to see that the intersection here between this reinforced concrete wall and the partition wall composed of the different material layers has a wrong intersection. Okay, so we want to also be able to edit the way these two elements compenetrate each other.
Ir dabar, kadangi šituo konkrečiu atveju neteisingas parodytas gelžbetonio ir kompozitinės mūrinės sienos susikirtimas, pademonstruos, kaip turėtų būti išspręstas šitas struktūrinis neatitikimas.
So in fact, if we go into the editor, this is also another interesting functionality. The editor allows me to therefore just quickly launch the element editor, which allows me therefore to set a priority when two elements come into contact. Okay, so we can decide which elements can penetrate into another element. Okay, as you can see in this picture.
Ir nustatant parametrus ir pirmenybinės taisyklės galima nustatyti, koks susijungimas tarp skirtingų kompozitinių elementų bus.
This also applies when we're looking at the building, let's say from a vertical split view. We can also see the internal objects, the internal arrangements for the floor plans. And here, let me just quickly show you how these views are generated by simply inserting the floor plan object in one of the levels. So we do all of the modeling in the levels. And once we have created the different floor plans or section views, we see them appearing at the bottom under drawing models. Okay?
Ir sumodeliavus aukštų erdvėse pačius aukštus, paskui patys brėžiniai atvaizduojami prie brėžinių skirsnio.
And here's an example of what we can achieve. This is just the basis, because we can therefore leverage the many different options that we have here in this particular set of drawings here. You can also see how the interface adapts again, providing me with 2D detailing, the possibility also to adopt different styles. So we can choose among the different default styles, or we can create our own. We can set them as default, or we can copy paste styles from one drawing to another. Here we have a more detailed view where we can also see the opening angles of our doors. and windows.
Brėžinių skirsnyje galima nustatyti vaizdavimo taisyklės, vaizdavimo stilius, galima tuos stilius ir vaizdavimo taisyklės perkelti nuo vienų brėžinių ant kitų brėžinių ir nustatyti, kad vaizdavimo stilius atitiktų brėžinių tikslą.
We also have the possibility to use, for instance, the measuring up of individual areas by simply clicking inside the different rooms. Take a quick look here. As we click inside a room, the software automatically inserts all of the measurements. Okay?
Ir yra tokių patogių įrankių, kaip matuoti kambarius ir išdėstyti kambarių matmenis tiesiog paspaudus porą mygtukų.
Or we can choose the dimension all function, which will automatically insert all of the measurements for the entire floor plan. Okay? We can do the same.
Arba galima paprašyti, kad visus uždėtų matmenis.
Now, in terms of a CAD user, this would typically have taken 50 different operations. In this case, we're doing it at a single click. And of course, we have the possibility to move the measurements around or delete any unnecessary measurements too.
Jeigu lyginant su AutoCAD, su dvimačiu projektavimu, tai tas visas matmenų sudėliojimas, jis jau užtruktų daug ilgiau negu naudojant šitos pakankamai gudrius įrankius.
The external measurements work in the same way, Rokas, in the sense that we just simply select which side we want to measure up and run a line across, and the measurements are also inserted automatically. So this
Ir
is
matmenų eilutės irgi taip pat paprastai dėliojasi, tiesiog nubrėžiama linija, kokiame gylyje matmenų eilutė pagal kokius parametrus prie ko turi prisirišti ir atitinkamai matmenų eilutė sugeneruojama, tai todėl lengva bus atitikti LSN standartus.
Same with other 2D detailing, because we already know the information contained within these objects are BIM related data, describing the thermal, physical, or mechanical characteristics of these objects. Whenever we use one of the 2D detailing or labels objects, the information is read directly from the object itself. As you can see here, we're inserting material legends, and these are automatically populated with all of the information.
Tinkamai dvimatė informacija apie dvimatį informaciją, jeigu jam ant grafinę dalį jinai paimama iš objektų, ar reikia padaryti eksplikaciją patikslinančią, ar tai reikia padaryti medžiagų bendras eksplikacijas su šitais įrankiais, tai pasidaro pakankamai greitai ir paprastai.
Here are some other options which allow us to customize the way we present our work. Of course, we're talking about highly detailed drawings. So we can also use the graphics tab here to add some extra, let's say, visual effects, such as material colors, shading. Okay. So give it a more artistic approach, and these can of course also be customized. Same with our section views, cutting through the stairs object, you can see there. And as we do it, these new nodes are being automatically added, where we see the automatic generation of section view, isometric view, or for instance, an elevation view.
Ir pasinaudojant lygiai taip pat lengvai automatiškai susigeneruoja pjūviai ir kiti reikalingi papildomi brėžiniai.
Let's take another quick look at the different custom options which allow me to let's say, add certain effects to my drawings. Here we're going to add another cross section, And what I'd like to point out here is the fact that all of the modifications that we see in the first floor, yes, this is the first floor, where we have inserted a section line. And here we see the drawing, which is generated at the bottom, dynamically generated here at the bottom.
Ir čionais įdėjus tas pjūvio linijas automatiškai generuojasi ir yra surišti kiti vaizdai.
A new feature that was recently added to the section line generation function was the possibility to also add a split section where we have a different depth of the section line. You can see here we're going to have two different section lines here, one towards the front here and one that goes further inside the central part of the building here. And you can notice how the drawing is automatically updated.
Ir taikant pjūvio liniją galima taikyti ją laužytą, kad būtų skirtingose vietose pjūviai atliekami skirtingų pastate ir gauti tokį pjūvį, koks reikalingas geriausiai perteikti idėjai.
So this more or less allows us all to understand how important it is to work with 3D BIM as our, let's say, methodology of being able to deal with the challenges of today's architectural design needs. Here we have another interesting view where we can activate the materials, choose how we want to represent the vegetation. Here's another view from one side. Okay. And because we haven't yet reached the final, let's say the final decision for our project, we haven't reached the final version of our project, we're still carrying out modifications. So it's very probable that at a certain point we may need to continue doing those modifications directly in 3D. And you'll be able to see that the relevant drawing, in this case the perspective view, is also updated live.
Ir čia svarbu, kad programa, kas Vilniui projektuoja, kad ypatingai gerai želdynus atvaizduojant pastatų fasadų ir keičiant pastato išorę, tokiu atveju taip pat keičiasi ir visi fasadai.
Okay, so there's this dynamic integration or connection, if you wish, between the modeling environment, whether it's 2D or 3D, and the construction documentation. Here we can see again another split view of our floor plan, where we have also activated the detailing, included our vegetation. We can also activate the material layers. So in this view here, we can see at the bottom how the material wall compositions can also be printed on paper or, let's say, exported as a PDF for approval. Once we have created our first, let's say, visual solution, we can also copy-paste that across to all of the other drawings. This is a quick preview of the real-time rendering, just to show you that this dynamic integration between 3D modeling and the documentation is also present when we're working, for instance, between real-time rendering, which you can now see here available on a second monitor. Edificius also supports usage on multiple monitors, so we can now undock the different views. Maybe we want to have 3D view and 2D view on one side and the 3D rendering view on the other. If I quickly show you a modification.
Dabar parodo, kaip atrodo, kaip veikia tas realaus laiko renderinimo mechanizmas, kad ta pati programa leidžia ir modifikuoti, ir dirbti su brėžiniais, ir su trimačia grafika vienu metu. Ir tai taip pat atsispindi viskas gyvai realaus laike grafinėme atvaizdavime, tam renderyje vadinamu.
Okay. So here we can see we're working on two monitors and we're keeping the real-time rendering process, which is inside of Edificius. It's not a separate software, so there's no need to do any importing or exporting. We have all of the information dynamically connected. It also means that we can see the effects of our design choices directly in the real-time rendering. Gives me a much more direct feedback of what I'm doing. We can also see those modifications taking place as we continue to do the modeling.
Kadangi tai yra ta pati programa ir kuri atlieka ir vizualizavimą gyvai susietą su modeliu, tai nereikia atnaujinti, perkelinėti ir per naują susijinėti modelio pagal pasikeitančią architektūros geometriją, o keičiant architektūrinės dalies brėžinius keičiasi ir vizualizacijos rezultatas.
So you can see that as we make a modification on the 3D model, the real-time rendering, the construction documentation are also dynamically updated. This is very important, of course, from a productivity point of view. Here we're going to add a cutaway drawing just to show you and understand about the important, the different and very important ways of representing our work to our clients. Here we can also use these interesting cutaway views to understand more about the internal organization in terms of internal design.
Rodo čia, kad galimybės galima dirbti labai įvairiais su programos pjūviais, padarant tokį pateikimą, koks atrodo priimtiniausias konkrečioje situacijoje.
And these now contribute to become these consistent images coming directly from the 3D view, which can therefore flow into our construction documentation too. Of course, sunlight simulation, because the site is geo-referenced, we also can run these sunlight simulations, or maybe if necessary, because we're talking about interoperability, we may want to export this architectural model as an IFC.
Programa irgi leidžia atlikti saulės simulacijas ir jeigu atrodo, kadangi visi modeliai yra geolokalizuoti ir galima taip pat eksportuoti, pilnas palaikymas yra EC failų sistemos.
I'd also like to show you now then another dedicated environment, which is the landscape modeler. Let's move forward and then uncover the terrain modeler. This is where we have, again, another dedicated interface, Rokas, where we see certain objects made available. This also allows me to choose my preferred way of doing my modeling. We can, of course, use another integration with Google Maps, which allows me, therefore, to import a certain section of the terrain profile of choice together with the satellite imagery.
Ir dabar demonstruoja tas terrain aplinkos modeliavimo aplinką, kuri taip pat yra integruota su tokiamis sistemomis kaip Google Maps, kad projektuojant galima įsikelti Google pateikiamą teritorijos reljefą kartu su satelitinėmis teritorijos nuotraukomis.
Here we can also see that as we focus on aligning the building to the terrain, we can use these object handles to raise the terrain according to the building itself and start to insert various objects. For instance, earthworks. We also have the terrain alignment tools, which allow me to align the exterior organization. This could probably be the cut and fill where the excavation works will be. And of course, the software is capable of also calculating how much terrain is being removed or added during these works.
Ir atitinkamai galima formuoti reljefą su įrankiais, nustatant principinius vertikalinio plano sprendimus ir formuojant programinę įrangą taip pat apskaičiuoja, kokie kiekiai žemės jie būtų nukasami ir supilami.
So here we're inserting, for instance, this ramp object. Notice how we're doing all of this in 3D. No other software solution allows you to do modeling of terrain, which implies very complex calculations from a geometrical point of view, directly in 3D. We can, of course, insert many other objects, such as roads and yards and landscape walls. This is a reinforced concrete retaining wall, for instance, here, which brings the road level here down to this patio area.
Ir pats geometrijos kūrimas ir reljefo elementų sukūrimas atsižvelgiant į aukščius geometrijos ir į pastato, jis atliekamas pakankamai paprastai naudojant programinę įrangą trimatėje erdvėje, lyginant su kitomis programinės įrangos sprendiniais, tai yra daug mažiau darbo sąnaudų reikalaujantis dalykas.
Here you can see I've also inserted some roads. There's also an area for the flower beds. So we're going to also define the garden layout using these important objects directly in 3D. So we can add all of these. You can also insert another important object, which could be a swimming pool. Again, this becomes a BIM object with its own properties. The same with the flower beds, where we're going to also insert vegetation.
Ir principo projektuojant tokius elementus, reljefas automatiškai jis prisitaiko prie suformuotų ir iš architekto pusės reikia tik dvimatėje erdvėje numatyti, koks jis turėtų būti, o programa pasufleruoja, kaip ta geometrija geriau ir paprasčiau išspręsta.
So the vegetation objects are also available for free in the library, where we can insert bushes, trees, and plants. Decide the way they are inserted and distributed along a surface or an area. So in this case, we decided to go for perimeter. And notice how these are inserted along a perimeter. Then we can insert each of these objects individually in a point-by-point workflow.
Ir gamtinius elementus, kraštovaizdžio medžius, želdynus galima tiek juos įdėti kaip atskirus objektus, tiek kaip ploto objektus, arba tiek kaip linijas, kad formuotų želdynų juostas priklausomai nuo poreikio.
Here we have materials which can be retrieved from the archive, the BIM object library. And now let's switch over very quickly to seeing the MEP systems design. Okay, this is also a very important topic I'd like to show you, and the capabilities of being able to deal with technical systems, electrical, plumbing, and HVAC systems can also be modeled without leaving the software at all.
Ir dabar parodys galimybės, kaip galima projektuoti ir modeliuoti inžinerinės sistemas, tos pačios sistemos programinės įrangos rėmuose, nenaudojant papildomų atskirų programinių įrangų.
Here we can see the many different kinds of objects referring to fire safety, HVAC system modeling, electrical, with all of the different relevant technical systems included inside. So here, for instance, we're going to focus on using the same building as before, hiding certain levels which we do not need. Okay, just to undercover the complexities of a very consistent and well-modeled technical system. Here we can see the heating, which can also be coded with the delivery and return pipe colors for both the air handling and for the heating systems.
Ir kaip matot, patys modeliai inžinerinių sistemų yra skirtingų disciplinų, ir elektrikos, ir vandentiekio, ir objektai yra labai, labai detalūs ir labai, labai tikslus.
So once we've set up the color coding for each of the different systems here listed on the right-hand side, we can therefore move over into 3D view and start to explore the different ways of inserting objects directly into the architectural project. We can do that, of course, in 2D if preferred. We can use some construction lines or construction grids to guide our way around. Here we have the many different objects which are available. These are called smart map objects. We can change their technical parameters if necessary and insert them into position. And for instance, we're doing that in 2D view. If we use a construction grid or the guidelines, these would be very useful when it comes to inserting the ducts or pipes. And of course, we can do that in 2D view too.
Sistema programinė įranga turi papildomą pagalbinių linijų sistemą, kurio dėka galima elementus inžinerinių sistemų išdėlioti paprasčiau, tvarkingiau, ir objektai, kurie taikomi, kiek yra pakankamai didelė biblioteka, tiek galima juos parametrus pakeisti ir pritaikyti pagal konkrečius poreikius.
So let me just give you a brief idea of how the modeling process works, both in 2D and in 3D. Okay, here we can see all of the different objects, which can also be customized. Okay. So here we're just simply inserting them as we would normally do in the CAD. But we're working in BIM, and not only are we working in BIM, we're working in Edificius, which is highly efficient. What I would like you to underline, Rokas, is the fact that in this particular view, we're using smart map with the automatic cross section. This means basically that as we insert the objects in 3D view, you can still see the architectural. But what's happening is that the software is cutting away all of the elements which we do not need, so that we can focus on reference points, for instance, the walls, the windows, the slabs, as we move around inserting the map objects.
Formuojant šituos MIP objektus yra pagalbinės priemonės, kurios padeda tvarkyti inžinerinių tinklų skirtimus tiek su architektūriniais, tiek su kitais inžineriniais tinklais, ko pasiekoje tas darbas gaunasi šiek tiek paprastesnis ir greitesnis.
So again, first of all, you see only the objects that you need when you need them, okay, with all of the relevant functionalities. And we're working in 3D. Notice how we have the capability to keep track of measurements, angles, okay, directly in this view.
Ir trimatėje erdvėje galima tvarkyti geometriją, nustatyti kampus ir dirbti tiksliai.
So we can do things in a much more intuitive manner because we see in 3D, we perceive in 3D. So it's more than obvious that modeling in 3D is a much more interesting and direct way of doing things. Let's insert some other objects, which you can see that will automatically adapt. We can choose them manually from the library, of course, and insert them into position, as you can see. Notice how when I inserted the object, the column appeared here. It appeared so that I also have a direct indication of any interferences with surrounding objects. It means basically that I'm doing a visual clash detection.
Ir šito pavyzdžiui, statant, kai atsirado šitas elementas, programa parodė, kad šitoje vietoje yra kolona ir galima susikirtimas su kolona, kuri šiaip buvo išjungta ir galima tada priimti sprendimą, kaip šitą situaciją spręsti.
Let's now continue in adding these ducts to the system. This is the ventilation system for our building. We have this ruler and also the goniometer, which gives me an indication of the angle between two different branches of this ducting system. So we can do everything directly in 3D with this very advanced way of doing MEP modeling. Okay. As we switch direction, the software will automatically switch to the most appropriate view. From the top here, you can see. Now, this is another interesting point, Rokas. I'd like you to underline this. The fact that as we continue the modeling process, the software is capable of fetching the elbow curve directly from the archive for me, without me having to go and search for it.
Noriu pabrėžti, kad projektuojant šitos, pavyzdžiui, kampinius elementus, tada pati programa supranta, kokie jungiamieji kampiniai elementai turėtų būti ir atrenka iš bibliotekos ir užbaigia šitą geometriją, pačiam nereikia eiti į biblioteką ir ieškoti tų elementų ir kažkaip užbaiginėti geometrijos.
So, as I confirm the length of this section here, the software automatically goes and collects the elbow curve for me. Okay, so it's doing half of the work for me as I continue to move around and select different objects to define the ducting system. Here we have another section, inserted this time in 2D. Again, we can see some modeling features here as we align and connect up this main section to the secondary section. And notice again how the software, with the smart map mode activated, goes in and fetches the correct T section directly from the library. Okay.
Ir čia irgi buvo parodyta, kaip, pavyzdžiui, kai reikėjo susikirtimą padaryti magistralių, kaip pati programa atrado teisingą T formos elementą sujungti reikiamus skerspjūvių vamzdžius ir kad nereikėjo parinkinėti rankiniu būdu, ir tai leidžia naudoti šitas smart modeliavimo režimas.
And here again, we can see some automatic adapting between objects based on the compatible, let's say, accessories available in the library, where from this box section, we can also adapt to a round section and insert, for instance, a flexible pipe, grabbing the diameter from the library and automatically connecting up this terminal. You may not notice what's happening, but the architectural model is being cut through dynamically as we move around.
Ir čionais darant, tiek objektai būna parenkami pagal inžinerinių sistemų parametrus, tiek, kas dabar grafiškai nesimato, bet atitinkamai architektūrinis modelis, jis yra koreguojamas pagal modeliuojamus tinklus ir jis yra iškertamos angos ir kiti dalykai ir pritaikomas prie modeliuojamos sistemos.
And this is more or less the idea of how you can do the entire modeling of an MEP system, no matter how complex, entirely in 3D, which is quite revolutionary. Of course, the true value point here is the fact that as you continue to navigate through the model, you have full control over your design choices. You have the possibility, therefore, to also create all of the detailing within the same solution.
Pabrėžia, kad dirbant šitą programą galima atlikti pakankamai detalų detalizavimą toje pačioje programinėje aplinkoje su ta pačia programinė įranga.
Here we have another accessory. We have a section change there. And again, here we can also finish off the modeling workflow very simply. Here's a general overview of the layout, where we can also see the delivery and return ducts, also in 3D view. This is a heating system where we can also see the radiators, the pipe delivery and return. Full control over every single aspect. And this is our radiator inserted into position, and for which we want to also provide the hot water supply and the return pipes. We have a multitude of different accessories subdivided into different categories: valves, regulation valves, pressure gauges, manometers, manifold collectors, and so on. They're all included in the library. And here we can see another.
Programa duoda galimybę pakankamai tiksliai išmodeliuoti visą ir inžinerinę įrangą, ir programa turi didelę biblioteką visos pildymo ar vandentiekio armatūros, kurią galima pakankamai lengvai prijungti ir įjungti į modelį, ar tai architektas tą norėtų padaryti, ar tai inžinierius.
If we have defined a certain path for the pipes, which can of course be very extensive in certain cases, we also have another function which speeds up the entire process. It's called the path replicator. It means that we can basically choose the path of reference, which in this case is this one here, and set a spacing distance between the different connection points. Here we can see the function working by simply selecting the intermediate spacing points. A simple click on the button, and these are automatically replicated. At this point, I just need to connect up the pipes, and notice how the elbow joints are inserted automatically, retrieving the correct type directly from the menu, directly from the archive. Here, another example of 3D modeling and how we can connect up to the radiator. also directly in 3D.
Jo, ir yra, kaip rodo daugybė modeliavimo pagalbinių įrankių, kurie padeda inžinerinės sistemas projektuoti ir modeliuoti šiek tiek paprasčiau ir taupant laiką, negu kad kiekvieną vamzdį ir kiekvieną jungtį atskirai.
If we can't find a certain object in the MEP library, ROCAS, we can also use the import from 3D model. In this case, we're going to use a SketchUp model, but we support 34 different 3D model formats.
Ir jeigu neužtektų turimų bibliotekų, tai galima importuoti SketchUp'o arba bet kokius kitus objektus. Sistema palaiko 34 skirtingas trimačias sistemas.
Yeah, so what I'd like to show you here is that this very simple SketchUp model can now become a smart map model within Edificius.
Ir dabar parodys, kaip SketchUpinis tiesiog neparametrinis modelis pasidaro protingu Edificus objektu, kurį galima keisti parametrus.
And we can do that by simply selecting the object itself in this assisted step-by-step creation, where we can set the connection points. This is the drainage output, and also the water inlet for the flushing tank. So we can see that at the bottom, and this is the water inlet that you can see here at the top. This is how the software knows where to connect up the pipes to. So in fact, if we insert it into position, it will automatically connect to the drainage. Okay. Same here for the water inlet. Of course, we also need a faucet or a regulation valve, call it whatever you prefer. So we can copy paste it from one object and bring it into another. And also connect up, you'll notice here, the flexible pipe from the tap directly to the water inlet that appears on the side of the flushing tank. Okay, so this gives you an idea of the main functionalities, which are quite extensive also when it comes down to producing our MEP system in electrical distribution. Here we can see a quick layout of our MEP system drawings, completed with tables, legends, and schedules.
Ir atitinkamai sumodeliavus pakankamai lengvai galima išspėti visą kitą reikalingą brėžiniuose informaciją ir apibūdinimus.
Here we have some other examples of a fire safety system with sprinklers, the capability also, of course, to compose our drawings relevantly to what we need, adding details, and keeping everything in a single approach. Here we also have, we'll see a little bit more about how this works. We can also generate an automatic bill of quantities directly from the MEP system. A simple click on the export button allows me to do so, or we can do things in a much more, let's say, manual way by simply dragging and dropping a price list item from the document here, which is represented on the left-hand side, fixing up various object variables. As we were saying, these are connected to the objects themselves. So we know the ID, we know where they are located, and we also know their measurements, allowing me to also build up a BOQ of the entire system.
Ir atitinkamai čia, kaip parodė, iš to pačio modelio galima pakankamai greitai ir efektyviai sugeneruoti sąmatą, susijęs su kainų duomenų bazėmis ir, ir kad sugeneruoja pakankamai tvarkingą tikslų žiniaraštį su kainomis ir suskaičiuoja bendrą vertė.
Maintaining our focus on the BOQ, we also have a specific environment here, which is called the BOQ environment, Primus. Primus is also another standalone solution provided by ACCA, but in this particular case, you'll see that it's integrated, provided for free inside of Edificius. How does this particular workflow function? We have a 2D view of the project and also the 3D view, and we also have the bill of quantities view. This is by definition what we also call the fifth dimension of BIM, when we are connecting the cost information to the 3D information of an object. Okay. Basically, what we have here is the possibility to load a price list document created in the Primus format, but of course, many users that do not have ACCA software solutions can also create a price list from an Excel spreadsheet. So if you have your price lists in Excel, we can bring them into Primus and use them within Edificius.
Ir čia dabar rodo, kaip susisieja pastato modelis, brėžiniai kartu su samata, ir ta samata yra generuojama iš pačio modelio, lygiai greičiai integruojant į arba duomenų bazės, kurie jie turi, patys susikūrė, arba jeigu yra kainų žiniaraščiai Excel lentelėje, galima susijęti su Excel žiniaraščiais, kas susijęs su kainom ir kad būtų tas visas samata daroma ir tikslinama.
So, you know, as architects and engineers or quantity surveyors, how important it is to keep the cost information of the project strictly aligned with the architectural design nature. Here what we're doing is we're simply connecting up a price list item for our window object. It has a unit rate, and what we want to do is now we want to retrieve the geometrical information, the measurements of these windows directly from the object itself. And we can do that by bringing up variables. These variables, which are represented between $sign, as you can see, we have the ID, description. We can also see where the object is by bringing up the floor level numbering. And in the geometry or the measurements fields, we can also bring up, for instance, the surface, the length, width, or the height. Okay, this gives me the square meters, which multiplied by the unit rate gives me the cost of a single window, which you can see appearing here in yellow.
Ir čia parodė, kaip galima skirtingus ištraukti objektų parametrus ir panaudoti juos samatoje skaičiuojant, kurie būtų svarbus būtent nustatant šito objekto kainą.
So now what do we want to do? We want to repeat this operation, don't we? So we want to have a bit of quantities which is consistent with all of the elements in our project. So to move forward, it's very simple to simply filter through all of the windows. You'll see them listed here. We have 51. Now you may think that we need to continue adding the variables for each one, but we have already created the measurement rule. It's already there for us. All we need to do is confirm by clicking the top level green checkbox, and notice how in one click the entire BOQ relevant to our Windows items has been built up. Okay?
Ir atitinkamai nustačius objekto skaičiavimo pagrindinių parametrų ištraukimo ir apskaičiavimo tvarką ir logiką, ta tvarka perskelia visiems kitiems visiems kitiems objektams persikelia.
Let's do another example when referring to the room areas or the compartments where we want to take into account, for instance, the pavement, the skirting boards, and maybe the plastering. The plastering, of course, will be taking into account also the openings in the wall. So it also needs to do a detraction of any surfaces due to the presence of doors or openings or even windows. So we'll search for the internal plaster, do a simple drag and drop over to the room entity, and you can see the variables and the measurement row box here will also appear. And here we can choose from the measurement models where the variables are already set up for me. And I can create these and save them for other projects or share them with my team collaborators. As you can see, this first room was inserted. It's calculated the surface for the walls and the ceiling, and it has also detracted the two doors, which are of course forming a negative value in the BOQ. Okay. Having done this for
Man
one,
kaip rodo, kad galima labai lengvai apskaičiuoti vidinės apdailos apdailas, atsivertinant angų kiekius ir taip pat tas taisyklės pritaikant ir perderint per visas patalpas esančios projekte.
having done this for one room, we can do it for all of the rooms, which are 9 in this particular case. So we have built up an automatic BOQ. But going back to what we were saying initially, Rokas, the fact that all of the different environments are connected between each other, and due to the fact that we're in a collaborative workflow, in some cases, changes are required. So what happens here is that even if we continue to do modeling, making adjustments to the model, we'll also be able to see, and I would like to highlight the values here in the BOQ listing, that is, as we make these modifications, both in either in 2D or in 3D, we're going to focus on this particular patio window here. If we make a variation, you'll be able to see that the total quantity here will also change. It means that we're focusing on different dimensions of the same object, geometrical and also cost related.
Ir labai svarbu, kad išlaikoma sąsaja tarp sąmatos ir pačio architektūrinio modelio, ir keičiantis architektūrai keičiasi ir atitinkamai kainos apskaičiavimo logika, ir taip pat iš sąmatos galima prieiti prie kiekvieno objekto, kuris išskirtas atskira eilute, ir tai, kad yra vienas duomenų šaltinis ir toje pačioje programos aplinkoje tas viskas daroma, mažina neatitikimų ir klaidų tikimybę.
So basically this window here, this patio window, is 10.08 square meters in surface, okay, given by the two values in width and height. If we make a variation, which is quite common, let's say, so we're going to, let's say, narrow this, the width here slightly, you'll be able to see that as we make the geometrical variation, the BOQ here is updated live. There's no need to do any exporting. Many other software solutions, you need to do a re-exporting, and you lose your position. You don't know where you are, you don't know where the variation was. But in this particular case, you don't even need to, because you know that the BOQ, which is dynamically connected to the model, notice how the value there changes to 5.15, okay? So we have this live synchronization, cost and 3D model.
Ir dabar parodė, kaip keičiantis architektūros formai, iškart architektūros sprendiniams keičiasi ir sąmata. Ir šitoj programoje išlaikomas sąryšis tarp vizualizavimo, sąmatos, architektūros ir inžinerinių dalių iš vieno duomenų šaltinio, neeksportuojant kažkaip per aplinkui tų failų.
So this provides an overview of the integrated nature of Edificius, of course. So you can see that everything is updated live, great quality in your work, highly professional, and also the integration with Primus. As I was saying, Primus, you can see here, is the leading software solution for bill of quantities and construction cost management. It was the first software developed by ACCA roughly 36 years ago. Okay, and it's also integrated in the sense that you can also bring in other important BOQ related information from other projects, other files, directly into, you can see we have the sticky note here with probably a file, a Primus file, which was saved by one of our colleagues that went on site. He sent the file to me, and I can just simply select the measurement rows that I need and bring them into the Edificius BOQ. If I now save and exit, I'll be able to see the very same information, the sticky notes and the images there connected to the different measurement rows, also available in my Edificius BOQ. Okay.
Ir čia, ką sakė, tai pas juos tas Primus programa yra kažkas kaip atitikmuo lietuviškai sistemai, tokia dominuojanti sąmatų ir statybos skaičiavimo programa, kuri irgi yra šitos įmonės pagaminta, ir kad tie visi sąmatos integruojasi ir eksportuojasi tą programą pirmyn ir atgal, tai labai svarbus, gal Lietuvai mažiau svarbus, bet dirbant su kokiais užsienio investuotojais gali būti irgi svarbus aspektas.
This is another example of how we can also move from a typical 2D CAD to 3D BIM. It involves the possibility to import our CAD drawings into Edificius. It's a very short video where I can show you how by importing a 2D floor plan in CAD, concentrated and limited just to the floor plan, we just simply run a section line over the CAD drawing and notice how the BIM objects are inserted automatically. Okay, so we're building the 3D BIM directly from the CAD entities.
Pavyzdį, kaip integruojant trimačius daugiau brėžinius, kaip pati programa atpažįsta dalį elementų ir kaip galima konstruoti trimačius pastatų modelius, remiantis dvimačiais brėžiniais, mažinant žmogaus darbą ir duodant programai daugiau atpažinti tai, kas yra nubraižyta.
It also works for doors and windows by doing the same thing. We can just simply run a line across and it will insert all of our doors and the windows, of course. Now, this sort of like brings our transition from CAD to BIM even closer, making things a little bit more easier. Nothing too complex to do because the software also allows you to speed up the process. Okay, so very, very intuitive and straightforward. This particular example here also shows you how we can transition from 2D CAD to advanced 3D BIM modeling and viewing. In fact, we also show you in this particular case how we can completely change the way we present our work by using real-time rendering. And here we have an example of the rendering of the entire building coming from the CAD floor plan layouts. Let's have a look now very quickly at the real-time rendering, which is based on Unreal Engine 5.5.
Parodys, kaip galima, kiek galima, kaip tai yra renderinimo tas mažina, tai šiek tiek platformos, kuriam galima atvaizduoti grafikai ir jinai paremta Unreal tuo varikliuku, dėl ko to vietoje jinai visada tokia labai atsinaujinanti ir lengvai valdoma.
So here you can see that we're in the real-time rendering, dynamic connection with the BIM model. You can see that there are also many different animated elements such as the water, trees. We also have animated people walking or doing certain actions. We can also see the climate effects, camera effects. You can see the trees there, which are also flowing in the wind. We can add
labai gyvas anturažas, medžiai, žmonės primena labai kitas vedančias panašaus profilio programinės įrangas, tik vienintelis skirtumas tas, kad tai yra tos pačios programos viduje, ne kaip atskira programinė įranga ir galima daryti įvairią tokią pakankamai su gyvu anturažu visą tą grafinę medžiagą ir animacinę tame tarpe.
Here we can see also the lighting effects, and we can of course add procedural grass, for instance, which grows according to our, let's say, to our preferences for this garden. So we can do all sorts of different modeling and experiencing the model directly in this real-time rendering view, including of course, sunlight simulations, artificial lighting simulations, so we can also see the artificial lighting during the nighttime, which of course allows me to communicate my design intent to the customer in a much more efficient and engaging manner. This is the interiors of our building. So we can see all sorts of different furniture arrangements, material choices, and this can be therefore communicated directly to the client via a direct navigation or by exporting a video presentation of our project. So there's no importing or exporting. Even if you need to make a variation or you need to do some extra updates to the model, we can continue to do so. And notice how the BIM model in the real-time rendering environment comes to life with these photorealistic effects. We have reflections, we have ambient lighting, we also have volumetric lighting. So you can take advantage of the best possible rendering engine, including animated vehicles, animated people, which, as I was saying, bring the entire project to life.
Ir kaip dabar parodė, kad programa puikiai reaguoja į apšviestumo dienos nustatymus, atitinkami objektai reaguoja ir įsijungia į naktinį režimą, yra apšvietimo efektai, atspindžiai, šešėliai, saulės judėjimo sekimas ir taip pat gyvas sąryšis su pagrindinė programa. Tai vietoje jai keičiantis keičiasi viskas interaktyviai.
Same applies to the interior design, Rokas, where you can see that even if we make modifications, the view on the left-hand side also dynamically updates.
Taip, dar kartelį pailiustravo, kad keičiantis architektūros sprendiniams atitinkamai keičiasi ir visa grafinė medžiaga ir per naują yra atnaujinama, ar tai animacija, ar tai stabilus paveiksliukai.
The visual styling also allows me to give a custom personalized touch to the way we produce our drawings or the visual output. So we can choose from different kinds of visual effects.
Ir taip pat galimi įvairūs vizualiniai efektai ir vizualiniai grafinio pateikimo stiliai.
Okay. The VR environment. Of course, this is another important aspect today because the most advanced technologies also require us to be able to engage with the customer and communicate in the most efficient form possible. And we can do that also with another integration, which is the VRI BIM, okay, virtual reality integrated in BIM. It allows me to interact with the model. You can see here we have an operator at the bottom right-hand side chatting away with the client and probably just showing some of the main features of his design. We can also move objects, but not only are we moving them in the VR view, we're also noticing at the top that the BIM model is also being modified. It means that we can engage in a new, let's say, participation with the modeling environment using VR and the, of course, the compatible headset with the hand controllers. So we can take measurements, we can change materials, we can delete objects. In fact, here you can see that the operator is measuring up the ceiling, taking the reading directly from the hand controller. He can, of course, delete objects from the model. You'll also be able to see that if the model updates, so do the construction drawings update.
Dabar parodo, kaip jų programa siejasi su virtualios realybės sistema. Šita sistema irgi yra tiesiogiai susijęta su pačiu modeliu ir keičiantis virtualioje realybėje galima ne tik peržiūrėti, bet ir įtakoti, keisti objektą, judinti įvairius daiktus ir atitinkamai padarius bet kokius pakeitimus ir virtualios realybės aplinkoje pasikeičia visas brėžinių komplektas, tame tarpe ir trimatis modelis ir dokumentacijos ir sąmatos.
So we can basically access all of the main functions that we saw previously, object-wise or even material-wise, and make all of our changes live in front of the client. We can also access documentation, believe it or not. So if an object is equipped with a PDF or an image or some other kind of important information, we can also read that information. Let's also see another important functionality, which is the static rendering, thanks to a partnership that we established with AMD. It's called AirBIM. These are some of the output capabilities of Edificius.